The idea of machines that can think like humans, or even better, appeared a long time ago in the minds of science fiction writers and crazy people from the past who had the courage to dream big. And today, AI seems to be everywhere you look. So how did we come from abstract ideas in books to virtual assistants or AI-generated pictures of pandas? This is Vadim from Go Magic, and you see there's a Go set in front of me, so inevitably the game of Go had to play a part in all of this. How? Let's explore and find out. The first primitive AI appeared around the 1950s, but the idea of AI had been in the minds of inventors, philosophers, writers, and even movie directors long before that. Leonardo da Vinci had some robot ideas back in the 15th century. Then there were some science fiction books written by Isaac Asimov and Douglas Adams that shaped the way people saw the future and robots. And even the word robot itself was coined by Czech writer Karl Čapek in his book Rossum's Universal Robots in 1920. That was 100 years ago. And he actually considered naming these machines labori, using the Latin root for work, or labor. And I guess we're just lucky that he decided to use his native language in the end and took the word robota, which meant forced manual labor. So, robots were conceived as hired workers that do the work for people. The concept of AI was formally introduced in the 1950s. Alan Turing, a British mathematician, and by the way, a Go player, proposed the idea of machines being able to think in his famous paper on the Turing test. And the test, if you're not familiar with it, was designed to see if a machine could show intelligent behavior indistinguishable from a human. So imagine that you interact with a machine and a human at the same time, and they don't tell you which is which. Now, the test is then whether you can reliably guess which one was the machine. If you can't, the machine passes the test. Of course, at the time the test was described, there was no machine that could even attempt to take it. Today, 70 years after the test was proposed, the machines are closer than ever to passing it, but still not quite there yet. So let's see what's been happening in this field in these 70 years. The term AI itself, or artificial intelligence, was coined by an American computer scientist, John McCarthy, when he organized the Dartmouth Conference in 1956. His vision was as follows. Every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. That's a very bold statement, but naturally machines had to start with something easier than just being human. So early AI focused on simple reasoning and logic. There were programs like the logic theorist and the general problem solver. They were developed to solve puzzles and mathematical problems. These early systems were limited because they couldn't learn from experience. They just followed predefined rules and couldn't adapt to new situations. AI pioneers made grand claims about AI's potential, and these promises raised really high expectations among the public and the funding agencies that machines will be able to perform any task a human could do within a generation. But despite initial successes in some controlled environments, AI systems struggled to generalize knowledge or deal with the unpredictability of real-world situations. Surprise, right? They also suffered from a lack of computational power. The AI algorithms of the time were just too expensive to be practical, given the limited hardware capabilities available. All of this caused a decline of interest for AI research, and that started a long hiatus known as the AI winter. The first one happened in the 70s, and I say the first one because there were more to follow in the 80s and 90s. Even though at the time the AI research wasn't very active, some interesting things were happening. I remember when I was a kid, I was reading a math book, and there was a chapter about menace. Despite the evil name, it just stands for Matchbox, Educable, Noughts and Crosses Engine. And for all of you Americans watching out there, this is tic-tac-toe we're talking about. They just called it menace because it just sounds better than met-TTTE or something like that. So what it was in principle the AI that was made out of matchboxes. There were a lot of them, and each matchbox was labeled with a game position. And so when the position arose, you would take the matchbox, you would open it, and pull out one of the beads that was inside of it. Each color of the beads represented the move that needed to be played. You would play that move, and then you continue the game. If you lose that game, you would put a penalty on the machine. You would take out all of the beads that led to their loss. And if you win the game, you would reward the machine and you would add those colored beads. After a while, the machine would learn to play better and better, sometimes better than its creator. So this kind of carrot and stick method proved quite efficient when learning simple games, not just tic-tac-toe. And this became known as reinforcement learning, when you are teaching the machine something and you're using a system of rewards and penalties to train it. It's like when you're trying a new video game for the first time and you make a lot of mistakes and your character probably dies many times. You start again and now avoid the same mistakes. The game cheers you on and gives you an occasional star, a banana, or even a mushroom. Then you make more mistakes, and then you continue this way, and you learn to be a better player. With the advent of more powerful computers and better algorithms in the 90s, AI started making a comeback. AI systems became capable of handling more complex tasks. At that time, a new kind of algorithm was being developed. It was called backpropagation, and it was akin to a teacher educating a student, or maybe a parent teaching a child. This is when you know the correct output for every input for the AI, and then you give it the input, you see what it does, and then you correct, and then you repeat that process. This is like, for example, when you're teaching the AI to make a cake, and you know what a cake tastes like. So you explain that to the AI and you ask it to make a cake. It puts some flour and water together and gives it to you. And then you say, no, this is no cake. You need more ingredients, salt, sugar, maybe some butter. Then the AI adds all of this and gives you another version. And you say, well, no, it's still a big mess. Maybe you need to put some cinnamon on top. And after a while, after many, many repetitions, the AI learned to make a good cake. And you say, yeah, this is a very nice cake. But there's a problem with this method. First of all, the AI is learning to make only one specific version of the cake. It cannot make a different one. And the bigger problem is that this way, the AI doesn't experiment. It is only learning to make the good thing, but avoids the excellent. We never know. Maybe there's a Michelin star cake available there somewhere if the AI is being creative. But we would never know, because the AI is making this cake that I have in mind. Nevertheless, the AI algorithms based on backpropagation and reinforcement learning began to be applied in more practical areas like speech recognition, handwriting recognition, and even playing games like chess. IBM's Deep Blue famously defeated world chess champion Garry Kasparov in 1997, and that was a major breakthrough for the AI. But it was still far from the distant dreams of AI creators about highly intelligent, self-learning machines that could reach the human level of reasoning or even surpass it. Deep Blue wasn't really perfect. Its strength came from some pre-programmed knowledge and computational power. It had the opening and endgame databases, and it didn't really learn to be a better chess player as it played. Now, the internet and digital technology led to an explosion of data, which AI could now use to learn and improve. This was the era of big data. With access to large datasets, AI systems could achieve higher accuracy and tackle more complex tasks. So there were more challenges to undertake, and one of these challenges lies in front of me. The game of Go uses a larger board, and the branching factor is much higher. There are just too many options at each game turn to be able to calculate all of them. Even increasing hardware power can't really fix this, because the number of moves to be calculated starts growing exponentially with each turn. Besides that, the objective in Go is a bit tricky to define for a machine. These black and white pieces can be captured during the game, and it would be easy to assume that whoever captures more wins. But in fact, the winner is determined by the size of board territory they surround, and capturing doesn't necessarily win you the game. And as if that wasn't enough, moves played in one part of the board often have an effect on the rest of the board in a very magical way. An experienced player will see right through it, but can a machine do that? For the longest time, they couldn't. This was eventually solved by Google's DeepMind when they created AlphaGo, a deep learning AI that combined several neural networks that would evaluate different parameters and then play millions of practice games against itself to get better. It used some human games for initial training, but it surpassed human knowledge at some point and developed its own strategies. That, in turn, allowed it to defeat world's strongest player in 2016. But we'll talk about that in more detail in our next video. The AlphaGo victory is important because it proved that AI can find patterns in real-life situations and make predictions based on them. And it can do that on human level or even above it. It was around that time, after 2010, that deep learning, a type of machine learning involving large neural networks, became the dominant approach in AI. These networks could learn to recognize complex patterns in data, leading to breakthroughs in image and speech recognition, natural language processing, and more. In order to create something as advanced as ChatGPT, for example, they had to combine many of the elements that we just covered. However, the idea of a chatbot wasn't really new. In fact, MIT professor Joseph Weizenbaum created the first chatbot named Eliza in the 1960s. It would take whatever you say to it and create a reply out of your input using some simple rules. Eliza was given a doctor-like script, so it would react to whatever you say in a way that is similar to a psychotherapist. But however basic it was still surprisingly efficient. There was a famous anecdote of his secretary asking him to leave the room so that she could have a word with Eliza in private. Even something as simple as Eliza had potential to be taken very seriously. And all of that happened so many years before people started pouring their hearts out to Siri or Alexa. So, some things never change. We've always been prone to giving human attributes to machines. That's why we always imagine robots to be shaped like us, even though they don't really have to be. And even though we anthropomorphize robots and AI, we really feel uneasy, scared, or even stronger negative emotions when we encounter robots that resemble us too closely. Why is that? I guess we just value our uniqueness and don't like it when somebody comes too close to being like us. This phenomenon is known as uncanny valley, and you can feel it by comparing your emotional reactions to some cute humanoid machines and then some of those AI with human resemblance. Look at them. How do they make you feel? In creating ChatGPT, researchers combined several elements. First, neural networks, the foundational structure that processes the information. Then there was deep learning, the multiple layers of neural networks that allow the model to understand complex patterns. There is some backpropagation, the method to fine-tune the network's accuracy. There's a bit of reinforcement learning. It improves the model based on feedback. And another very important thing, transformer architecture. It enables understanding of context and relationships in data. It's like a diamond that's being studied from different angles and under different lights to reveal different facets and nuances. Like an orchestra conductor with absolute pitch who can hear every instrument, even if there are hundreds of them, and who can then harmonize them to create beautiful music. Other modern AI that appear everywhere today use all of the things that we just talked about and keep moving forward. For example, they also have convolutional neural networks, CNNs, the visual processors that can notice specific patterns in images. Then they have generative adversarial networks, or GANs. Two dueling neural networks are created to compete with each other. One of them is the generator, the other is the discriminator. And for example, the first one tries to create a perfect forgery of a Van Gogh painting that would fool the other one. And they keep doing this back and forth, one trying to fool the other and the other trying to see through the forgery. And this way, this interplay allows the generator to learn very efficiently. Then there are also diffusion models that are turning noise into art. These models start with random noise and progressively turn it into meaningful data. It's as if a sculptor is starting with a rough block and chiseling away to reveal a statue. This algorithm is used in high-quality image generation, for example. The creator of YouTube's mobile app, Andrei Doronichev, once said in an interview that AI is now becoming another breakthrough service available to everyone. Intelligence on tap, as he called it. Just imagine, for years and years, for the longest time, people would take and carry water from wells and rivers and lakes until one day, a major change happened. There was this water supply system. Now water became available to everyone in their homes. You don't have to go anywhere. Then there was another evolution, electricity. Now electricity is available in your apartment. Imagine how people lived without it 100 years ago. Then there was the computers, then the internet, and now AI is joining this list. Right now, as we speak, AI becomes available as a service. At this point in history, in 2024, we don't really know how this is going to pan out and how far AI development will go. But it certainly seems that the future has a lot of exciting things in store for all of us. And if you don't want to miss other videos like this one, then give it a like, subscribe, and I'll see you guys in the next videos. This is Go Magic.